male brain, female brain. Are they actually fundamentally different? I mean, this is a question that has been debated forever, right? It's launched 1,000 books, sparked endless arguments, and it really shapes how we think about ourselves. So today, we're going to try and cut through all that noise and get to what the science is actually telling us. Let's get right into it.
And you know, right at the heart of this whole thing, you've got two completely opposite views from some really smart scientists. On one side, you have the hardwired camp. The idea that our brains come pre-programmed, with certain strengths based on our sex. But then on the other side, you have the idea that the brain is this incredibly dynamic thing, mostly shaped by the life we live. So which is it? Are our brains a fixed blueprint? Or are they a sculpture shaped by life?
Okay, so to really get a grip on where we are today, you have to realize this question is not new, not by a long shot. For centuries, people have been searching for that one simple biological reason to explain the differences we see between men and women.
And the hunt for an answer, well, it's kind of taken us from the outside of the head all the way in. I mean, first they were literally measuring skulls with calipers. Then they were mapping bumps on the head with phrenology. After that, they started looking at hormones. And now, today, we have these amazing fMRI scans that let us peek inside a living, working brain. But here's the thing. Even with all this incredible technology, the basic question and all the arguments around it, they're still here.
All right, let's dive into the first big idea here. This is the evolutionary blueprint perspective. It says that our brains are not blank slates at all. Instead, they're the result of millions of years of evolution, shaped by the very different challenges our male and female ancestors had to overcome to have kids and pass on their genes.
So what's the engine driving this idea? It's something called sexual selection. You've probably heard of survival of the fittest, right? Well, this is more like reproduction of the fittest. It's not just about staying alive. It's about being able to pass your genes to the next generation. And the pressures to do that can be really, really different for males and females. Okay, so how does this actually work? It all starts with those different reproductive pressures. From there, you get two really powerful forces. First, you get competition inside one sex, like guys competing with other guys for status or resources. And second, you get choice between the sexes, like females choosing the best partner to have offspring with. Over thousands and thousands of years, these two forces act like a filter, pushing brains to develop slightly different strategies and tendencies.
So, according to folks like evolutionary psychologist David Geary, this process doesn't create totally different brains, but it leads to these distinct biases, and this is key, on average. For males, this tends to look like a drive for status, an edge in physical competition, and a real interest in how things work. For females, the focus tends to be more on choosing a mate, nurturing, building very close one-on-one friendships, and being really tuned into social and emotional cues. That's the evolutionary blueprint theory in a nutshell.
Okay, but that's just one side of the coin. There's this whole other powerful idea, which argues that the most amazing thing about our brain isn't some ancient blueprint, but its incredible ability to change throughout our entire lives. This is the idea of the brain as a sculpture, constantly being shaped by the world we live in.
And neuroscientist Gina Rippin puts it perfectly. It's not just our genes calling all the shots. It's this constant back and forth between our biology and our environment. Our experiences, the culture we grow up in, what people expect of us, all of that is actively carving out the pathways in our brain.
Just picture a baby's brain for a second. From the moment it's born, it's not just sitting there waiting for instructions. It's this active, rule-hungry scavenger. It's constantly scanning the world, looking for patterns, trying to figure out the rules of the game. And it's especially hungry for social rules. What does it mean to be a boy in this world? What does it mean to be a girl? It picks up clues from everything. Toys, TV, parents, friends, and starts wiring itself based on that information.
All right, let's get into some actual data. See this number, -0.48? That's the effect size for the male advantage in mental rotation. Picturing objects and turning them around in your mind. It's one of the most famous gender differences out there. But in statistical terms, that's considered a small to moderate difference. What it really means is that the overlap between men and women on this skill is absolutely huge.
So that brings us to the million-dollar question, right? Even for a well-known difference like this one, where does it come from? Was it there from birth, or did we learn it?
Well, this is where the plasticity argument really comes in. We know for a fact that things that boys are often encouraged to do, like playing certain video games or with construction toys, directly train and improve this exact skill. And get this, studies have shown actual physical changes in the brain's gray matter after just 3 months of practicing a spatial task.
This suggests that experience can literally, physically build the very skills we tend to think are just hardwired from birth. So you might be thinking, okay, this is an interesting debate, but why does it matter? Well, it matters a lot, because how we answer this blueprint or sculpture question has massive consequences for how we raise our kids, how we teach them in school, and really, how we build our entire society.
And the stakes? They can be life and death. Just look at this. According to data cited by Dr. Leonard Sachs, teenage boys and young men are 10 times more likely to die in drowning accidents than girls their age. That points to a huge difference in risk-taking. So what do? Do you ignore a difference like this in the name of equality and maybe put boys at risk? Or do you focus on it and risk reinforcing a harmful stereotype?
And this exact problem, it plays out in our schools every single day. If you take a gender-blind approach, you might end up misdiagnosing normal boy behavior, like fidgeting or taking risks, as a disorder. But if you take a gender-aware approach, you risk putting kids in boxes, maybe steering boys away from reading or assuming girls can't handle a tough physics class. It's a real minefield, and either path has big potential downsides.
So where are we with all this? Are we just robots playing out some ancient genetic script, or are we completely blank slates shaped by culture? Well, it turns out the modern thinking that's the wrong question to even be asking.
You know, science has pretty much moved past that old nature versus nurture debate. The real answer is so much more complicated and honestly way more interesting. It's not one versus the other. It's both, always. It's more like a constant dance, a feedback loop between our biology and our world that never, ever stops.
I love this analogy to help make sense of it all. Think about your brain like a brand new smartphone. When you take it out of the box, it has a certain operating system, some default apps pre-installed. That's got like your evolutionary blueprint. But what makes that phone yours? It's the apps you download, the pictures you take, the contacts you add, the way you customize it. That's your experience, your culture. The hardware and the software are completely entangled. You can't separate them.
So what's the big takeaway here? It's not a simple answer, but it's a much more profound one. We have predispositions, but not predestination. We are born with a blueprint, but our lives provide the architecture. How does knowing this, that we're both an ancient blueprint and a world-shaped sculpture, change how we see ourselves, and maybe more importantly, how we see each other?